Hello guys, welcome to another video in the series of coding. Today we are going to do the problem. It's called shortest unique prefix for every word. So given an array of words, you have to find all shortest unique prefixes to represent each word in the given array. Assume that no word is a prefix of another. Let's try to take an example to understand this. So we have 4 words in this example. Now let's see the first word. If we just consider Z for it, there is no other word which is having Z as the prefix, right? So there is no other word which is having Z as the prefix. So for this unique and the shortest prefix for a zebra, it will be Z itself, because there is no other word which has Z as the prefix. Okay, but if you take the second word, now if you try to just give D as a prefix for dog, it will match with duck, it will match with dove. So D cannot be the answer for this. Okay, so let's try the next possible shortest. Let us try DO. Let's try DO as a prefix. Now it will match with dove, because dove also has DO as the prefix, dog also has DO as the prefix. DO is common. Prefix just means a small substring which is inserted in the front. So DO is the prefix for both of them, right? So DO can also not be the answer. So for dog, the prefix that is the answer is DOG itself. Okay, this is the answer. For zebra, the answer is Z. For dog, the answer is DOG. Now let's consider the next word, duck. Now for duck, let us try giving the shortest prefix, which is D. It will match with dove, it will match with dog. So we cannot give D. Let's try giving DU. So if we see, DU is not matching with any of the possible words. So DU is one possible answer for duck. Okay. Now let's go to the next word, dove. Now for dove, let's try giving D. We can't give D because it will match with dog and duck, right? Both of them have D in common with this. So we cannot give D. Let's try giving DO. Now DO will match with dog. If we give DO, DO will match with dog also. Both of them have DO as the prefix. So this is also not allowed. So the prefix that is shortest and unique. So it's important that the prefix has to be unique and also it has to be shortest. So we can give DOV. So these are the following answers. Now if we try the brute force approach, right? So for every such word, you will have to try to match it with all such words. And when you are matching with all such words, again you will have to compare character by character and try to match. That is brute force approach, which is worst, right, in terms of time complexity. So how to obtain a better solution? So we can use a data structure which is called Trie. Now what is this Trie data structure? It's very simple. Taking the example of a C++, what you do, you just have a node. So we just have a node, and now in this Trie data structure, what we are going to do, now we are going to store an array, and in that array we have pointers to this node again. Okay, and we have one variable. Now let's see one variable which we will call frequency. How will that help to solve this problem? So see, what we are basically doing is, first let's see how we are going to solve the problem using this Trie data structure. So I'm going to build a Trie using these 4 words, right? So let me start. So first I have zebra, right? So first I have root. Okay, then I have for Z I have a node representing something, and then I have a node for E. So let me try to see if I can write a little bit bigger, okay, so that it's visible. Okay, so I have, for Z I have a node, so this is my root. Then corresponding to E I have a node, corresponding to B I have a node, corresponding to R I have a node, and corresponding to A also I have a node. Okay, now for each corresponding to each node, that is also, we can also give a frequency variable, right? So let's say frequency. So initially when we are seeing Z is occurring 1, so the frequency is 1. For E, the frequency is 1. For B, the frequency is 1. For R, the frequency is 1. For A, the frequency is 1. Okay, so now we will go to the next word. Next word is dog, right? So again we will start from the root, and we see that in the root, right? So basically what is this? This is a node. I have written a very simplistic form, but consider this is a big node, right? In this, now I have 2 data members, right? One data member is an int type which will have frequency. Okay, another data member is an array, and that array is of length 26. Okay, so that array is going to be of length 26, so that I can have all the characters. So from index 0 to 25, and 0 corresponds to a 1 corresponds to B, 2 corresponds to C, and so on, right? So I have all the characters. Now in this array, again I'll be storing pointers to nodes, right? I'll be storing pointers to nodes, and this will be one of the trie nodes that I have. Okay, so what do I mean by that? Now let's see. Let's discuss. So the small nodes that I am writing, this is a large scale node representation. Each of the node has 2 data members. Okay, now we will see again and again what we are doing, and it will become clearer. So now next word is dog, right? So how are we going to represent dog? So we have dog. So let's go alphabet by alphabet. First alphabet is D. So what we will do, inside the root there is this array, right? In this array we will check if at the third position, right, at the third position in this array, if this is null or not. Because if this is null, okay, so if this is null, that means that there is no character in my current trie structure which is starting with D. Okay, so currently this will be null because I have not yet inserted D. If it is null, what I am going to do, I am going to go here, I am going to go at this place, and I am going to remove this null, and here I am going to create a new node attached here. So I am going to attach a new node and create a new node at this position. So that's what I am doing in my trie data structure, right? So now let's see. So here I am going to go and create a new node. Okay, and this means at the third index I will do that. So it will correspond to the alphabet D. Okay, and I will also give its frequency as 1 because as of now D is occurring once. Okay, next I will go and create similarly O, and I will create G. Okay, everything is occurring once as of now. So for dog also I have exhausted all the characters. Now let me go to the next possible word. Now I have duck. Okay, I will do the same thing. Now when I am seeing D, right, when I am seeing D, now I am starting from the root again. I am starting from the root. Now when I go here, right, I go here, this will not be null. This will be pointing to a node. This will be pointing to a node. This is my root. Consider this is my root. This will be pointing to another node. It will not be null because see, this is pointing to this node because I have stored a node already here, right? This pointing to a node. So how do I solve it? Because D is already present, it is not null, right? So here what I will do, I will just go and increment the frequency. I will increment the frequency of D to 2. Okay, I will not create a new node, rather in the node that is already existing I will go and increment the frequency, and the frequency will become equal to 2. Okay, now I will go to O. Now O, sorry, I am seeing duck, right? So I need to create U is not existing, so I will create a new node. So in this node, right, in this node what I will do, see, this is my node, I will magnify it. This is my node corresponding to D, right? Now in this there are there's going to be an array. So at the position corresponding to U, it will currently be null, so I will go and create a new node there. Okay, so that's what we are doing. When we write the code, I hope it will be clearer, but just for understanding sake. Okay, so I am going to go there and I am going to create a new node. Now I am going to create a new node, and that will correspond to U, because at the youth position, I mean at whatever the index of U is, at that position I have gone here in that array and I have created a new node. Okay, pointer to the new node. And now I am going to do the same thing for C, and I am going to do the same thing for K. So I have created my trie. Okay, and the frequency is what? Frequency of U is 1, C is 1, and K is 1. Okay, now let me quickly do the same thing for dove, right? So I have dove, right? So first I will go and I will check at the Dth position. D means at the third index. Now it is existing, right? It is existing. So let me take red color. It is existing. So it is existing. So what I will do, I will just go and change my frequency. Now my frequency becomes equal to 3. Now I will go to the next. Next is O, right? Next is O. In dove, next is O. So again I will change the frequency. Frequency will become equal to 2. O is occurring 2 times. Now I have to create a new node, because now nodes are not existing, and the frequency is 1. Here also the frequency is 1. Okay, so I have created my trie data structure. Now how do I solve this problem using trie? It is very simple. Now after building this trie, right, I will just iterate over all the words. For example, let me see the first word. First word is zebra. So I will start from the root node, and I will check. So at Z itself my frequency is 1. For Z my frequency is 1. That means no other word is clashing, no other prefix, no other word has a prefix z, because my frequency is 1. If some other word had a prefix of z, my frequency will not be 1, it will be greater than 1, but here the frequency is 1. That means that z is the answer. Okay, that means for this z is the answer. Very easily we can find out. Okay, now let's see for dog. For dog, now I'll again start from the root. Okay, I'll again start from the root, and I am visiting this d. Now I am seeing that the frequency is 3. That means what? 2 other words apart from me share the prefix d. That is true, right? Because the frequency is 3. That means 2 other words, dog, duck and dove, everything are going to share the prefix 3. That means that d cannot be my answer. So d cannot be my answer. So I will go to the next node. I will try the next possible prefix. So I will go to o. I am looking at dog, right? So d is not the answer. So I will try o. Now for o also the frequency is 2. I can simply look at the frequency variable. The frequency is 2. That means do can also not be my answer. I am sharing with someone else. I am not unique. In this question you have to find out the unique prefix. If I am sharing, how can I be unique? So this is also not the answer. I will go to the next g. Now for g the frequency is 1. That means dog is the answer. Okay, dog is the answer. Very simple. So now we have come back. Dog is the answer. Okay, for this dog is the answer. Now let's see for duck. For duck we will do the same thing. We will start with d. Frequency is 3. That means 3 can never be the answer. Now we will go to u. Frequency is 1. Very good. So we have found a unique prefix, because frequency is just 1. I am not sharing this prefix with anyone else. So the answer for this is du. Now let's go to dove. Okay, so we will start with d. Frequency is 3. This cannot be my answer. I will go to o. Frequency is 2. This cannot be my answer. I will go to v. The frequency is 1. That means this is my answer. This is the unique prefix. So the answer is dov. Okay, so that's it. Now let us quickly go on to coding it, and then it will be clearer. So first of all we have to build the trie data structure that we just discussed, right? So that is the first thing that we have to do. So I will create a struct. Okay, so I will create a struct. So in C++ for a struct, by default the members are public. That's why I'm creating a struct. Okay, so struct trie node. Okay. Now this struct, right, this is the struct that I have. It's a structure that I have. Now this has 2 data members. So one is frequency, which we just discussed, right? One is frequency, and what is the other thing that we discussed? So trie node star, and let me call the array that we just discussed, let me give it a name. Let me call it child. Okay, this is a child that will have trie node star. Okay, now I will make its size equal to 26, because from 0 to 25 I have the indexes. I will cover all the alphabets A to Z. Only we need small alphabets, so for covering everything up to A to Z. Now I'll give a constructor for this. Okay, let me give a constructor for this. Now in this constructor, why I need a constructor? Because I can initialize easily. So I will make the frequency initially equal to 0. So whenever I need to initialize easily using my constructor, I can initialize. And for int I equal to 0, I less than 26, I plus plus, so I can just give child of I is equal to null. So initially everything is null and the frequency is 0. Okay, that's it, done. So we have created struct trie node. Okay, now we will go in this class, and what we will do, we will create an instance of this. So trie node. Okay, so I will call it root. So trie node star root is equal to new trie node. Now I will use my root. Okay, so I will use my root. So basically I am just creating the trie. So what we just discussed, this trie I have to create, right? I have to create this trie first, and then we will check whenever the frequency is 1, that will be our answer. So I will have to create a trie. So what I will do, in my function for int I equal to 0, I less than n, I plus plus, for each of the word I have to build trie. So I will give a function build trie. So we will write that function. I am going to build the trie, right? So I am going to build the trie. So for each of the word I am going to build a trie. So I will pass this and I will build the trie. Okay, after building the trie we will have to build the prefix. So we will give 2 functions. So first is build trie and the second function is build the prefix, and that's it. So now we also have to return an answer, right, after building all the prefixes. So let me give answer. Okay, so let me give a vector answer, and now whenever we are building the prefix, right, we will push them in our answer. That's it, we'll push them in our answer, and finally we can return answer. So that's it. Now we have to just write the functions build, try and build prefix. Okay, so let's write the function build, try. Writing the function build, try. So void build try. Okay, void build try. And what are we taking? So we are taking two things. What are we taking? One, we are taking the string, and we are also taking the root. So we have the root. Okay, now let's start building the try. So how are you going to build the try? So let's see how are we building the try. So basically, first we have a root, right? So in the root, okay, so in the root, let's say we are building for zebra. So whenever we have a null value, right? So whenever we have a null value, okay, let me try to take another example. So we have a root, right? Let's say we have to build for zebra. So in this, so this is the root. Currently frequency is 0, okay, and everything is null. So if we have to build, so start with z, right? Start with z. Z corresponds to index number 25. Okay, z corresponds to 25 here. So at 25, if it is null, then corresponding to that you have to give a new try node. Okay, and after giving a new try node, you have to increment its frequency to 1. That's what we are going to do. Okay, so let's see that. So for int I equal to 0, I less than s dot length, I plus plus. Okay, so what is the first thing that you have to do? Get the index. Okay, get the index of the current character. For example, if this is z, so z minus the ASCII value of a, okay, that will give 25. If it is z, if we are building zebra, let's consider that example. So this is z, s of I will be z. So this will give you the 25th index. Now add the 25th index, right? Okay, so first of all, let me give current here. So okay, so now this is the current pointer, right? So so this is the current pointer. Now currently we are at this node. Now at this node, what we are going to do, at the 25th, first of all we have to check if it is null or not. Okay, so we have to check if it is null or not. So if current's child, okay, so we have given, so let's look at the data structure try node again. So we have called this array child, right? So I am using the pointer, right? I am accessing the child data member, and in the child, at the particular index, right, at the index which we just discussed, for example at the 25th index, what I'm going to do, I am checking if it is null or not. If it is null, how can you increase the frequency? If it is null, you have to declare a new node. Okay, so if it is null, that means what? That means declare a new try node, because otherwise how can you increment the frequency if it is null? Okay, if it is not null, just increase the frequency. Okay, if it is not null, very good, just increase the frequency. So we will go to that index, and okay, so we'll access the child data member, and at that particular index we will go and we will increment its frequency. For example, here if it is null, we will create a new node. Okay, and we will create a new node and we will make the frequency equal to 1. Okay, if it was not null previously itself, if it was not null, we will simply go and increment the frequency. Okay, that's it. That's what we are doing. So we will just go there and we will increment the frequency. So if it was 0, it will become 1. If it was non-zero also, it doesn't matter. If it was 1, it will become 2. If it was 3, it will become 4. If it was 100, it will become 101. Okay, so how many times that is occurring, we are just incrementing the frequency. That's it. Now after this, what you have to do, very simple, that's it, just go to the next possible index. So we are going to the next possible index. So for example here, so now we have come to this node corresponds to z, and we'll do the same thing again. So now we have to insert e, right? So we have to insert e, because in zebra the next letter is e. So here we will go at this node which corresponds to z. So we will go at the 5th position. Again we will do the same thing. Okay, we will do the same thing at 5th position. If a node doesn't exist, what we'll do, we'll go and create a node. We'll create its frequency equal to 1, and this node corresponds to e. Okay, again we'll do the same thing for the next b, and so on. So that's why our current pointer will keep shifting, and then current pointer will keep shifting. We'll keep creating nodes till we write down all the alphabets that exist. Okay, for example zebra. So that's it. So this is a build try function. Now after we have built try, what are we doing? We are also building the prefix. So this is the next function. Okay, so whenever we are building a prefix, we are also returning the string that is getting added to our answer. So let me write the build prefix function. So we have a string and we have trie node star root. Okay, so let me just write. See, it's these first two lines are same only. Okay, so first you have a current and you have to keep doing it till this. Now what you have to do, you have to just check if the frequency is 1, right? Till that time until you get a frequency equal to 1, you have to keep. Okay, so first I will give this condition. If current's frequency becomes equal to 1, in that condition I can break, right? In that condition I can break. Let me also declare an answer string that I am going to return. So string answer is equal to this, and finally I am going to return answer. Now also to answer I can keep adding s of I. Okay, and I will also take the same thing. So int index is what? So I'm just taking this line from here, just like we found out index here, so we can also find out index here. Okay, so this is the index, and this is the same line, current is equal to current's child of index. Okay, that's it. So I hope that this will work. Let's compile and see if it's going to work. So it's working. Let's submit and see if it's working. So it's working. Thank you for being patient and listening.